Hello, my name is Michael Sparks, and this is my SSI Fellowship application. So who am I? What do I do? Well, who am I? Well, I'm a researcher and software engineer. I'm interested in impactful innovation and sustainable computing. I've been involved in volunteering and open source over the years, and I'm interested in enabling and mentoring people. Some of the key highlights here: I'm a software engineer, computer science background. BBC Microbit is something I created in the kitchen. I've helped found PyCon UK. I've founded BBC R&D's North Lab. I've been involved with Google Summer of Code. I've been mentoring. I've been involved in open source for a number of years. I'm interested in sustainable computing, green metrics. So what do I do? Early roles: worked for Manchester Computing, worked for InkSme, then joined BBC R&D, worked there for 22 years, then recently joined the University of Manchester. What did I do in the early days? Lots of the stuff in the early days was to do with web caching. Some of this was national scale, which is at Janet, and some of this was international and global scale, which was InkSme. Generally involved using things like networking, C, Linux, reliability at scale, the collaboration tools and training, and various other knowledge sharing involved. BBC R&D involved leadership, helped found BBC R&D North Lab, got the BBC involved with open source, released a lot of open source, been involved in collaborative projects, so some to do with things like object-based media, changing the way studios are built out, mass participation, and building out the BBC Microbit. So talking about impact, some of the early stuff, but Camellia led to the podcasting trials, which then led to BBC Sounds eventually. BBC Microbit changed the way that computer science is taught in schools. IP Studio changed the way that we build out studios. These are agile, lean, open source patents. And at the University of Manchester, I've been working on the eVerse project, which is the RSQ kit, which is a collaborative EU project. This is working with the science clusters. It's around facilitating physicists to have better software stories, not just physicists, because it's all the science clusters, and it's around knowledge sharing. In terms of green compute, this is in the context of high energy physics. So this involves metrics collection, monitoring, prediction, brainstorm, been involved with the sustainability working group. Finally, on connections, been involved with collaborations workshop, various different physics-related workshops, and also took the university to PyCon UK, and we had a really successful stand and a bunch of sprints there. So that's who I am and what I do. So my proposal is compilepython.com, which will contain guidance, support, and how to compile Python programs for real-world problems for green compute and performance reasons. That's the plan, and we'll come to it. So once upon a collaborations workshop, Matt Gilman said, if Python's so bad for the environment, why not compile Python C++? And I said, it's not that easy for a hack day or more, but it's noodled around my head since. Python's green compute problem is that it's both popular and slow. Now, if you combine those two and you consider the environment, that's how much it's used. But if you combine that with both being popular and slow, actual problem is significantly greater if you weight the popularity. What's green compute problem? Well, low performance means more energy. More energy is more CO2. Poor performance, bad for the environment. Obvious implications for dynamic languages. It's also estimated that data centers use as much energy as aviation. It's quibbled, but of the same ballpark. So what's the solution? CompilePython.com. If you just said that, people would turn around and say, no, that's not real. You know it's a hard problem. Why doesn't that work? And if it was that easy, everyone would do it. Where can I get info? What can work? Many people have tried doing this in the past. Many have had issues, incomplete, fragmented knowledge in the community limits usage. Even I've written a couple for different reasons. So what's the solution? Because Python isn't going away. Well, it's CompilePython.com. Let's make something real. We solve hard problems by working together. It's a place for sharing problems and solving them. Nothing's ever easy when you start out. A place where you can get info and you can share what does work. So the proposal is to create a website, CompilePython.com. Think TripAdvisor for Python compiler tools. So laundry list of tools, real-world experiences, descriptions of subsets used by each one, how-to guides, credible, maintainable, and a lean-first approach. So I've registered the domain and not another Python compiler, which is incomplete. I've written 2 specialized Python compilers in the past, so I'm credible on that front. I've tried using a number of these tools in the past. They all have foibles. What really is missing is a place to share experiences and get help. I've built online and in-person communities in the past, and I've got a track record of working on difficult things. I think a Python compiler is probably doable, but this is a necessary first step. So who? Without collaboration, this simply can't scale. So the aim is to reach out specific research groups developing Python compilers and individuals. That will involve the UK Python community, EuroPython community, international Python community, and academic communities. This will have impact because it will be knowledge collation, not just another broken tool. Focus on community building, sharing of best practices, cross-cutting focus increases the relevance for everyone, so it's not just performance for performance sake. The plan is as follows. So, 4 content phases, 1 per quarter with a PyLightning camp in each one. So an unconference, open space type formats, 3 online, 1 in-person hybrid. Then a final publication phase with captures to Zenodo, some sort of publishing system, maybe Amazon, Lulu, LeanPub, using GitHub as a collaboration point, static website, promotion at events, inviting people to join. So Q1, Detailed planning, infrastructure build out, invitation, promotions, events with an online camp at the end. Q2, more content writing, invites, promotion events, and building hopefully an MVP of a living guidebook style. Q3 would be an active in-person hybrid event, either similar RSECon, PyCon UK, or similar, with a prototype site hopefully complete, with the first wave of content appearing, in-person event hopefully focusing on compiler authors, and plans for Q4 and 5 refined. Where do we take it from there? Q4 would be consolidation. So it's working with the community to finalize a longevity plan. So version content, scalable delivery, open call for experience reports, and finalizing that plan. Q5 is executing on that longevity plan. So one aspect might be a PDF ebook published using various means, perhaps using Amazon KDP, Lulu, LeanPub, Zenodo. And I've used all of those in the past for different purposes. So that's the plan. Thank you for your time.